So I'm Divna. Thank you for coming. This is what I do normally. I'm a Byzantinist. That means I study medieval Greek stuff. And most of the time, I look at diagrams such as this one. And what I propose to do today is similar to what Richard did in the morning. I'm going to show you a round circular object, and we are going to figure out what it means from multiple perspectives. But since he asked me also to do a provocation, I decided to do two things. One of them is to borrow a structure of a joke to tell you this story. Not because I'm a very good person when it comes to telling jokes, actually to the contrary, but I think the light bulb jokes are something that we are all familiar with, and they provide a very, very clear structure. So they usually start with a question, and you're all familiar with this kind of questions. There is a whole category about light bulb science jokes, like, so how many postdocs does it take to change a light bulb? And then there will be a punchline, a very clear answer. Well, it depends on the size of your grant. And this would be our question today. It's a bit more serious. So how many disciplines does it take to understand the medieval diagram? And the second thing we're going to do, and I'm very happy to speak second in this session, is that we are going to play a game. And you've just heard about embarrassment and games and adults playing games. So no embarrassment is needed here because you all have an envelope and everything you need to know is written inside. So I will just explain briefly how this game should go. And apologies for scripting everything, but since we have very short time, I couldn't allow you to improvise way too much. So basically, look at your envelopes, and you see one of three pictures. So some of you will have a hand, others will have a diagram, and somebody will have an astronomer looking through an instrument towards. This is on the envelope, not inside of the envelope. Yeah, I did a lot of cutting and pasting yesterday. So first, take a look and decide which of the three you have. If you have the hand, that means you are assigned the role of the paleographer, or the person who studies ancient handwriting and historical manuscripts, who can read them for us, transcribe them for us. If you have a diagram, that means that you have been assigned the role of the art historian, so you can interpret figures and shapes and forms and colors. And if you have the astronomer, obviously, you have been assigned the role of an astronomer. Now, you can open the envelopes, and inside you'll find your scripts. And we'll just role-play each of those parts. And we'll start with the paleographers. So that will be the first example which the paleographers will have. And if you are a paleographer, can one of you please tell us what we see here? That will be number one on your cheat sheets. You don't have to be embarrassed, you can just read it.
Sphere of the sun.
Can you say it louder?
Heliosphera.
Sphere of the sun. So this is what we see here. So we've learned something. We've learned that there is the sun, and there's an inscription that tells us this. Can another paleographer tell us what we see here? Selenisphere. So, in translation, because you have the translation as well. Sphere of the moon. And you can see the little moons, right? And there will be a third task for the paleographers. So what is written here? Yes, which means?
The Earth's shadow.
The Earth's shadow. Thank you, paleographers. So thanks to you, we have seen parts of the diagrams, and we know that there is a part about the sun, a part about the moon, and there is this black conic shape, which is the Earth's shadow. Thank you. So now let's move to a bit more difficult and abstract, let's say conceptual part, the role of the art historians. So one thing that the art historian can talk about is color theory. So can one of the art historians just read us whatever they can tell us about the color theory based on the script you have? Yes?
This one employs colour to distinguish between lights and darkness.
I think it's a bit longer.
Yeah. Red ink is used to indicate the sun as the main light source, and the surfaces of the moon and fixed stars that are lit by it. Interestingly, the intensity of the light received by stars closer and further away from the sun is clearly distinguished. Those closer are indicated by both red outline and red fill, whereas the surfaces of those further away are signalled by red outline only and a shape without the fill of colour.
Thank you. And I'm trying to point out these things as you read them, so I hope you could see the sun, the stars which are closer, there is red fill, and here there is just red outline. So the person who did this already helps us understand what's closer, what's far away, and which is the main light source in this system. And now can another of the art historians tell us a little bit about another thing we can learn from this diagram, namely a little bit about symmetry and how a diagram tries to create dimensionality.
The diagram is copied on the flat surface of the folio but depicts a three-dimensional space, a spherical cosmos. It creates the impression of depth in various ways. It uses color to indicate degrees of illumination based on position and distance from the sun. Also, it is perfectly symmetrical with one exception. The central axis in its upper half does not extend in the lower. This is a visual cue that the bottom half is shown rotating around the central axis.
Thank you. So you can see the central axis, and you see how it's not here anymore. And we're supposed to imagine this lower part, that is the sun, rotating around the central axis and the Earth in the center, sort of in a three-dimensional way. Thank you. And now we go to the third group, the group of the astronomers. And here in your cheat sheet, you have excerpts from a 14th century school book, which try to explain what is shown to us in this diagram. So that would be the first part an astronomer can focus on. And can one of the astronomers just read this textbook for us?
It was mentioned that the moon does not have its own light, but its light comes from the sun. Whenever it is in opposition to the sun and near the ascending or descending nodes, the Earth is exactly on the line between the sun and the moon. The light of the sun is missing from the moon, and the moon has died. At that time we say the moon is eclipsed. The eclipse of the moon is said to be caused by this.
Thank you. And another thing an astronomer could say, which is not about the eclipse, would be about the central part of the diagram, and that would be a different subject. Can another astronomer read it for us? It's from the same textbook.
This part of the diagram shows the lunar phases, full moon, though eclipsed, gibbous, half moon, and the crescent moon. The moon is spherical and bright, that is, it shines like a mirror. Its body does not have its own light. The moon emits the light from the sun, which makes the moon bright. When the moon is in conjunction, synode, the half of the sphere of the moon on which the sun shines is above, and the half in our direction remains dark. For this reason, we cannot see the light from the moon because it lies above. Whenever the moon is in opposition, the half of the moon's sphere, which is in our direction, receives light from the sun, and for this reason we see the full moon. Whenever the moon is near conjunction, it appears faint, and when near opposition, it is bright. In this manner, we sketch the phases of the moon in the diagram.
Thank you. So by now, we have heard from the polyographers and from the art historians and from the astronomers. And we have amassed a vast amount of knowledge about different aspects of this image. We have also read specific texts from the same period that this image was made from. And another point of view that I didn't include in your envelopes, but of course, next to the polyographer, to the art historian, to the astronomer, we can add other people, like the historian who can tell us that this was done in a period when astronomy was rising, and they can explain why was that was the case. And there is, of course, the literary historian, for instance, who may think about this text from the 11th century that imagines, and I'll just read this for you, that imagines what the sun would have said to the moon if the moon was annoyed and its high position. So what the sun would say is the following: "My dear moon, why say nothing before but start now? Why are you begrudging the fact that I have a bigger circle than yours, illuminated at every point and assigned lordship over the day? While my light is very pure and radiant, yours is rather dark when it is not from me, and all its partial brightness comes to you from my rays. You should have always yielded me the primacy as it was thus ordained by God. You are at the boundary between stable reality and creation, and are the last body in the heaven, while as for me, I stand in the very center of pure nature, bestowing my own light equally both on those above and on you below." So as you can see, there are many, many points of view that, from which we can approach the diagram, but all of them tend to be rather fragmentary. So let's say we started with the paleographers, from whom we learned about different parts, different inscriptions that the diagram presents to us. They can read it to us, they can tell us what the labels say. Then we needed the art historians to discuss issues of color that related also to issues of spatiality, of three-dimensionality, of depth. And we needed also the astronomers to explain what actually is happening, that it is a lunar eclipse, or that we see the phases of the moon. And then we can add all these other people in order to get the fuller picture. And with this, I want to come again to the joke and to the provocation and to our initial question. So how many of us does it take to understand the medieval diagram? And my answer is very simple and not at all clever. But I think, just all of us, as long as we talk to each other. And in this sense, for my provocation today, you all have received an envelope that presents one of those three positions. So I provoke you to find another person that has a different envelope than yours and to spend the coffee break or whatever, or the reception, just talking to them. Thank you.
I'm a paleographer, but I don't know my own business here. So I'm really interested in the teardrop or eye shape in the sun. Divna, do we know what that is?
Tom, this is a very nice question for both paleographers and astronomers.
Cool.
So this thing is the traditional symbol for the sun in Byzantine manuscripts.
Okay.
So there are two things that are happening here. First, you have the traditional symbol. If you were a Byzantine person, you would know, okay, this is the sun. Mm-hmm. So you don't need the circular shape around it. So the circular shape around it is added to add emphasis to the light of the sun, to actually have a bigger, according to me, there's no proof to any of these things. But I think it is because it gives you more space to introduce more color to emphasize the impact of light. And as to paleography, the same symbol, but imagine it much smaller, was used also just as a simple bookmark. So like a passage in a text could be noted with the same symbol, and then you have a sort of footnote in the margin with this symbol. So I think it's really nice that the symbol for the sun also has another application when it comes to medieval footnotes.
That's great. And do you mind? I have another note on the hand, so I've got you. I'm going to get to the bottom of this. In the shadow of the earth, there are three moons, not one.
Yeah.
Does the text explain that?
No, I think it's about three positions of the moon in a way, because on the one hand, this is also where the full moon is supposed to be. I mean, within this circle of phases, this is where the full moon is supposed to be. So I think one of them, I really don't know which one, right? But I think one of them is supposed to stand for the phase. So here we are supposed to have a full moon. Then another one would indicate that, well, but this is also what an eclipsed moon looks like. And about the third, I don't have any idea. I just assume the sequence of moon shapes also helps indicate the space of the Earth's shadow.
Right. Just the other possibility is, given that the three different sizes of those three, it's known, of course, that it's been known for a long time that the moon's distance from the Earth varies really quite significantly around its orbit, and it may be illustrative of the fact that there are eclipses which coincide with apogee and eclipses that coincide with perigee, and they look a bit different.
Yeah.
I don't know.
And this would be, if that's the case, which I cannot prove either, but if that's the case, it would be another argument for three-dimensionality of the diagram. No?
Yeah, well, except if you do what you said before and stand it up, then the shadow of the Earth sticks up, which is the wrong thing for it to do. So I wasn't persuaded by that.
I think it's also about my computer skills. I mean, I imagine it in my head in a 3D version much better, but I just couldn't do it.